Right, okay, we're carrying on with this insulation infrared sort of worksheet. Right, in this question, so remember what we said about the color black. Black is a good absorber of infrared radiation. It's a good emitter as well. Radiation. Oh, come on. Radiation. Right, it's also a good emitter of radiation. White is a poor conductor. Poor conductor of infrared radiation. Right, you also have air is a poor conductor. And why though? Because remember the particles are further apart. Particles, so conductor, right? Particles are far apart, so they can't vibrate and pass on their energy to the next particle. And trapped air is a poor conductor. Let me rephrase that. Trapped air. Trapped air reduces or stops thermal energy loss. I just want to put these words in: thermal energy being lost through what? How does it lose it? Through convection currents. So let's put that all into our heads. Right, okay. Cat X has no fur and light colored, so that's a light color. White, and this is dark colored stroke black. So we should be thinking in these terms, yeah. It has no fur. So what you can do is you'll heat the air up here, and that will form a convection current, or you'll get energy loss through there. This has got fur, so it's got trapped air, and fur is a poor conductor of heat anyway, trapped air, yeah. So all this is going on. Both cats have the same body temperature and transfer energy to their surroundings when they are outside on a cold day. So we know that energy is going to go that way. Compare how cat X and Y transfer energy. So we can talk about all three: conduction, convection, and radiation. So conduction is through vibration, it passes it on. Convection is the movement of, in this case, gas particles, and radiation is done through infrared. Right, okay, so we need to somehow write all that down. And right, this is where this is going to come in, this trapped air. Let's run with that. Let's go with it. So we're going to say cat X loses more energy by conduction and convection than cat Y. Let's get rid of that. Right, why is that? which is x and y. So cat x and y. Okay. Conduction and convection. Right. Right. Cat y has fur, which is a 4 conductor of heat, and it traps air. So what happens? Trapped air is a poor conductor, or in this case we'll say a good insulator. Trapped air is a good insulator, and trapped air stops convection, as air can't move. Right. There's a poor conductor. Okay, so here what we could have done is we could have also, I suppose, put instead of a poor is a good insulator. Right. Also, black or dark surfaces are good emitters of infrared radiation. So cat Y will lose more energy by radiation than cat X. Okay, that should do it. So look, we've concentrated on cat X. It's going to lose more energy by conduction and convection than cat Y. We've then said cat Y has fur, which is a good insulator. Can I go over that? Or a poor conductor of heat. And it also traps air. So if it traps air, what happens? Trapped air is a good insulator, and trapped air stops convection currents. We can say that. Or heat loss by convection. Right. Also now we've got black surfaces. Remember what we said? Black surfaces are good emitters. Right. So cat Y, which has got a black layer of black fur on it. So cat Y will lose more energy by radiation because of the fact that it's a darker color. Right, let's move on. Right, same idea. Look, it's a 6 marker. So what you've got is, if you notice straight away, shiny. You've got plastic lid, they've highlighted. You've got a vacuum. Vacuum means no particles inside. No particles means no convection, and then there's no conduction either. Right, a shiny surface means that you've got bad or poor conductors that way, and that way it's a poor emitter of infrared radiation. Right, we've got to put all that in somehow. You've also plastic lid. Plastic is a poor conductor, and it stops conductor. Plus, it stops. God, did I just do that? Yes, I did. How silly is that? Plus, it stops convection currents. So any heat, any particles that are heated and want to go up, they'll hit that and then they'll have to come down. So the heat, the thermal energy will stay inside. Even whether it's in, let's just say that it's full, yeah. So the liquid will start, there'll be no evaporation either. So there's a lot going on here. So somehow we need to put that into words. Good luck. Right, so the first statement that you want to make, how the design keeps the drink hot. So the cup slows down the energy transfer to the surroundings. Right, how did it do that? Right, so with regards to conduction, so this is how they've laid it out. They've talking about conduction first. Right, the vacuum contains no particles so conduction doesn't happen. The plastic lid is a poor conductor of heat or thermal energy. Oh, it's a good insulator. Right, now we move on to convection. The lid traps the air inside the cup, reducing convection currents. Okay, so there's your particle, there's your liquid, there's the lid. So any convection currents that were going to take thermal energy away are just forced back down, so it keeps the thermal energy in. Yeah, okay, that's it. So conduction, convection, and finally radiation. And let's do radiation. Radiation. So how is radiation reduced? The shiny or the silver or the white, the shiny surface inside is a poor absorber of infrared radiation or thermal radiation, and the shiny surface on the outside is a poor emitter of infrared radiation, so heat loss is reduced. Radiation, right? So heat loss or energy loss by radiation is reduced or minimized or stopped. Ooh, right, okay, so can you see how they've done that? So the first statement that they made was that the cup slows down the energy transfer to the surroundings. So that's how they've started it, right? Okay. Then they started saying, right, the vacuum contains no particles, so conduction doesn't happen. The plastic lid is a poor conductor, so energy loss is reduced. The lid traps, not a good idea that one. Let's try this one. The lid traps air inside the cup, reducing convection. And then finally what they've done is I'll have to use you. The shiny surface or the white surface or the silver surface, okay, all three, just remember that, are poor absorbers of infrared radiation on the inside, and the shiny surface on the outside is a poor emitter. So the inside is not absorbing it, the outside is not emitting it. So the energy lost by radiation is minimized or reduced. Right, done. The next one is dog. Yeah, we'll do the dog one on its own on the next video. Right, okay, done.